Greetings, fellow grade 11s. It is Mr. Tlajayo here. Welcome to Back to Basics, right? Now, what we are looking at today, we are looking at our exponential equations, right? So we are attempting different types of, exam types of questions to see in terms of how can we go about in solving these types of questions whenever we are given, right? So we're going to start with something that is very much basic. Now let's look at the first one. What is that you are given here? So now looking at this one, you are having 0.125 to the power of x, which is equal to 0.25. Now, what is this going to be? Now, I want you to have an understanding that 0.125, now this is same as what? This is same as your 1 over 8 close brackets to the power of x. This is same as what? And when you do 0.25, I think we all know that 0.25, it's a quarter, which means this is going to be same as 1 over 4. Out again. Now, what is the next thing that you are going to do now from here? Now you are going to write this in a what? You are going to write this in an exponential form, which means this is same as 1 over, this is 2 cubed. Now close brackets to the power of x. This is same as 1 over 4. Rather, the 4 can also be written in terms of what? The 4 can also be written in terms of 2 squared, right? Altogether. So which means this is going to be same as 2 squared altogether. Now, which is what you are going to have. And from here, now we know that from the law that we can say, for an example, if you're having a to the power of negative 1, right? So this is same as 1 to the power of a, right? 1 over a, which means now if you're having 1 over a, this can still be written in terms of 1 to the power of negative 1, right? So what is that you're going to do here? Which means this can be written in terms of 2 to the power of negative 3, then this is to the power of x, then this is same as what? This is also same as 2 to the power of negative 2. Again, now that the bases are the same, right? So which means now since the bases are the same, we can drop our exponent, right? So which means this is going to be same as negative 3x is equals to negative 2. Okay, and then now from here you are going to divide by negative 3, you are going to divide by negative 3, which means the value of your x that you are having in here, it is same as what? It is same as 2 over 3. Are we all fine, right? So basically now that's what we are going to have now from here. Now let's look at the next question and see what is that we are doing here. Now in the next question, what you have here, you are having x, right? So this is same as x. This is x to the power of negative 2 over 3. Now this is equals to, right? This is going to be same as 0.25. Out again. Now I think by now we know that what is 0.25, right? So which means 0.25, we know this is same as 1 over 4, right? Which means this is same as x to the power of negative 2 over 3 is equals to, this is same as 1 over 4, which is same as 1 over 2, right? So which means this is actually same as x to the power of negative 2. All right, this is negative 2 over 3 is equals to 1. This is same as 2 to the power of negative 2, right? So what I've done here, I've written my 2, or rather my 4 in terms of 2 squared. Out again. And now from here, because what I want us to do, I want us to get rid of the exponents because we are trying to solve for x here, right? So now when we are solving for x, what is it that you are going to have here? So which means now you are going to come back here and multiply both sides, right? You are going to come here and multiply both sides by what? You are going to multiply both sides by negative 3 over 2, right? Multiply both sides by negative 3 over 2. Are we all fine, right? So which means this and these, they are going to cancel. The 3 and the 3 are going to cancel. So which means here you're having x, and here the 2 and the 2 are going to cancel, which means here you're going to have 2 to the power of 3, right? Because negative and negative gives you positive, right? Because here, remember here you're having negative 2 and here it's also negative 3 over 2, right? So which means now your value of your x that you're going to have, this is same as your what? This is same as your 8. Are we fine, right? So basically now that's what we are having here. Now, I want us to quickly move swiftly along to now our number 3, right? So let's just make up our space here quickly, right? So this is quickly, we are making up our space here so that we can look at number 3. Now, what is that we can do when we look at number 3, right? So in number 3, So where are we going to start? Now, in number 3, you are given that you're having 2 to the power of x, right? This is equals to what? This is equals to 1, right? Now, we know that from the law of exponent, right? I can write my 1 as what? As 2 to the power of 0. Oh, it's okay, right? Because 2 to the power of 0 still gives me 1, right? Now, the reason why I want to do that, I want to end up having the same bases, right? So which means this is going to be 2 to the power of what? To the power of 0, which is still the same as 1, right? Now that my bases are the same, which means now I can drop my base and I can solve that my x is going to be same as what? My x is going to be 0. Are we all fine, right? So basically now that's what we are going to do now from here. After this, let's look at something, right? Now, what is it that you're having here? Now, here, this is 1 over 3. This is 1 over 3. Close bracket, this is same as x minus 1 minus, this is same as minus 9 is equals to 0. Now, what is the first thing that we can do now from here? So we can start by obviously distributing the what? Distributing the 9 this other side, which means this is same as 1 over 3. This is x minus 1. This is same as what? 9. And remember that my 9, I can write my 9 as 3 squared. Altogether. Now, because here I have my 1 over 3, right? I want to change the 1 over 3 and write it in terms of 3, right? So which means this is same as 3 to the power of negative 1. And then to the power of also x minus 1 is equals to 3. This is going to be 3 squared. Altogether. And now from here, what is that I'm going to do? Now I am going to multiply the negative 1 everywhere in the brackets, right? So which means this is same as 3 to the power of, this is negative x, and then this is going to be what? This is going to be positive 1, right? What I'm doing here, I am distributing the negative 1 everywhere in the what? In the exponent. So this is same as also 3 to the power of 2. And now from here, what is it that I'm going to have here? This is same as negative x plus 1. It's same as 2. So which means now this is same as negative x is same as what? Now what is this going to be? This is same as 2 minus 1, right? So 2 minus 1, this is same as 1. And therefore, which means our x is going to be same as what? Your x is going to be same as negative 1 when you divide by negative 1 both sides. Right? So which means the solution of the x that you are going to have there, this is going to be same as our negative 1, right? Now, so let's just continue and see what else then now are we having. Let's look at number 5, right? Let's make up our space here so that we can look at number 5 and see in terms of how do we go about solving our number 5, right? So now in number 5, let's just make up our space here, right? Now from here, what is it that we're going to have here? For an example, this is same as now, for an example, this is same as 2. This is 2 to the power of 2x plus 3. Plus, this is same as 4 to the power of x is equals to 72 multiplied by 2. This is to the power of what? Of 3x. Are we fine, right? Now, what is it then that you are going to do? Now, from here, I want you to look at this and look at this carefully, right? Now, what is it then that you are having here? Number 1, we need to solve everything here and write it in prime factors, right? And now, what is it then that you are going to do now from here? Remember 2. Now, 2 it's same as in its prime factors. So this is same as 2 to the power of 2x plus 3. Then this is going to be same as plus. Now, what is 4? Now, 4, can you see that 4? It's same as 2 squared, right? So this is 2 squared. Then to the power of x. This is equal to, now, when you go to your calculator, right? Now, when you look at now your 72, right? So now when you say 72 equals to shift effect, what is it then that you are having here, right? Let's just check in our calculator in terms of what is it that you are going to end up having here, right? Now this is same as what? This is same as your 2, right? If we look at this, this is same as 2 to the power of what? Now this is going to be same as your 2 to the power of 3 multiplied by 3, what? Multiplied by 3 squared, right? But now we can just still just allow this to be the same thing, right? So we can just still let this to be what? This is same as what? Let this to be 72 multiplied by 3 to the power of what? Of 3x, so that we can solve this side firstly, right? So now from here, I want us to write this in factor form, what we are having on the side, right? So this is same as 2 to the power of 2x multiplied by 2 to the power of 3. This is plus, this is same as 2 to the power of what? 2x. Now this is same as what? This is same as 72, right? This is same as 72. Why did I write 3 here, right? This is same as 2 to the power of 3, right? So this is same as 2 to the power of 3. This is multiplied by 2 to the power of 3x, right? Now from here, I want us to take out a common factor here. I want you to see that here we have a common factor, right? The common factor is same as what? Same as 2x and also 2x, right? So which means when I say this is 2 to the power of 2x, then when I open my bracket, what is that I'm having here? So I'm left with 2 cubed. Now this is 2 cubed plus 1 because here there is nothing, right? Now this is same as what? This is same as 72 multiplied by 2 to the power of what? 2 to the power of 3x. And now from here, what is it then that I'm going to do from here? Now, can you see that this is going to be same as what? This is same as 2 to the power of 2x into bracket. Now, when you say 2 squared, right? Now, 2 cubed rather, this is 8 plus 1, which is going to give us 9, right? So this is same as 9 into, this is same as 72. This is 72 multiplied by what? Multiplied by 2 to the power of 3x, right? Now, what is it that we can do now from here? We can, go either of the side. For an example, we can start here, divide by 9 and come here and divide by 9, right? So when you are dividing by 9 both sides, you are going to left with 2 to the power of 2x is equals to, when you say 72, divide by 9, this is same as 8 multiplied by 2 to the power of 3x. Altogether. And now the 8, right? I think all of us understand that the 8, we can still change it and write it in terms of 2, right? So which means this is same as 2 to the power of 2x is equals to, this is same as 2 to the power of 3 multiplied by 2 to the power of 3x, right? So basically now this is what you are going to have. Now we are going to multiply powers of the same base, right? So which means this is same as 2 to the power of what? 2 to the power of 2x is equals to, now this is same as 2 to the power of 3x. This is going to be plus what? This is plus 3, right? This is 3x plus 3, or this is same as 3 plus 3x, one and the same thing, right? Now that the bases are the same, now we can drop them, right? So if we drop the base, what is it that you're going to end up having here? So this is same as 2x, right? 2x is equals to 3x plus what? Plus 3. Are we all fine? And then now we can group like terms. We can take the 3x this side. This is same as 3x minus 2x. Then this is same as negative 3, which means now the value of our x is going to be same as what? As negative 3. Okay, so basically now that's what we are going to have in this particular question, right? So I am hoping that this makes sense. Now let's move swiftly along, right? I want us to look at your this is going to be 6.3. Now let me make, or rather 6. Why am I saying 6.3? I'm looking at my number 6, right? To see in terms of what is that I can do now. I know probably I'm adding some of the steps which, might not be necessary, but they are necessary for deepening of your own understanding, right? Okay. So now let's continue swiftly along and see what else then now are you having from here. Right now, let's look at now our number 6. Now, in number 6, we are having 3 to the power of x, right? 3 to the power of x is equals to, this is 8 multiplied by, this is same as, or 3, this is 8 plus, this is 9 multiplied by, this is same as 3 to the power of negative x, isn't it, right? And then now, what is it then that you're going to do now from here? So, what is it that you're going to do? Firstly, we can start here. Now, we can start by, firstly, writing this in this format, right? So this, remember, this is same as 3 to the power of x is equals to 3. Now we can start by, making this in this way, right? So I can write this in terms of, this is same as 3 to the power of what? 3x minus, let's say I take this one, this side, this is same as minus, this is 9 multiplied by 3 to the power of negative x, right? This is going to be same as plus, or rather minus 8 also, right? This is minus 8 is equals to 0. Right, again. And now from here, I want to write this as a positive exponent so that I can start working. So this is same as 3 to the power of x minus, this is going to be same as 9 multiplied by what? 1 over 3x. This is going to be same as minus 8 is equals to 0. Now from here, I am going to multiply, right? I am going to multiply the entire expression by what? By 3x. So I am going to multiply everything by 3 to the power of x so that I can get rid of my denominator, right? So which means this is same as 3 to the power of what? Remember when I say 3x and also multiply by 3x, this is same as 3 to the power of 2x, right? Because when you multiply powers of the same base, you do what? You add the exponents. Now this is subtract 9 because when you say 1 over 3x multiplied by 3x, these two are going to cancel each other, right? So this is minus 9 minus 8 times what? 3 to the power of x is equals to 0. Now from here, this is same as 3 to the power of 2x minus, this is same as 8 multiplied by what? 3x. This is minus what? Minus 9 is equals to 0, right? Now from here, now I know that, from here we can what? We can actually factorize this, right? We can actually factorize this because this is same as squared, this is same as x, and this is a constant, right? So this is our quadratic equation, right? So if this is our quadratic equations, what is it that you're going to have here? For an example, now you can open up your two brackets, right? You can open up your two brackets and equate to 0. This is same as 3 to the power of x, right? This is also 3 to the power of x, right? All together. And then what else then now are you going to have here? Let's see, this is going to be same as, now to get the factors of 8, this is going, or of the middle term 8 here, this is going to be same as 9 and also 1, right? So this is going to be same as negative and this is going to be same as positive, right? So which means this is same as what now? This is same as 3 to the power of x minus 9 is equals to 0, or this is same as 3 to the power of x plus 1, right, is equals to 0. Now from here, what is it that you're going to do? Now this is 3 to the power of x is equals to what is 9. When I transpose the side, this is same as 3 squared, right? So which means my x is 2. But now if I come back the side, can you see this is same as what? 3 to the power of x is equals to negative 1. And then when you solve this, you are not going to find a solution, right? So this is no solution. It's okay, right? So basically now this is what you're going to do. I know some, might preferably want to use K method, which is still, much more user friendly. It's okay. So now let's continue with our 7 and see in terms of what is it then that you're going to do. Like, let's look at number 7, right? So now, which is our last one. I know probably, I've said a lot in this particular video, but now let's just look at the last one. And then I am done for this particular video, right? Now let's look at our number 7. In number 7, what is it that you are having here? Here you are having x. This is same as x minus. What else then now are you having here? Now you are having 4, right? This is same as 4x 1 over 2 minus 5 is equals to 0, right? Now, what is it then that you are going to do from here? I want you to have an understanding. What is 1, right? I think I want you to see this, that this is actually same as what? Now, for an example, remember 1 in terms of half. How can I express 1 in terms of half? Isn't it that 1 over 2 multiply 1 over 2 plus 1 over 2 gives me 1, right? So which means I can still consider this as my quadratic equation, right? Because for an example, I can open up my two brackets here and say this is equal to 0. Then I say this is x, this is also x 1 over 2, right? This is x to the power of 1 over 2. And then now I am looking for my 5 so that I can get the factors. This is same as 5 and 1. Because the middle term is negative, this is going to be negative. But because the last term is negative, then this must be positive so that I end up having the last term as my negative, right? So, and then now from here, what is it then that you are going to do? This is same as x to the power of 1 over 2 is equals to 5, right? And or rather, let me just, yes, this is equals to 5. Oh, this is same as x to the power of 1 over 2. It's same as what? As negative 1. What is it then that you're going to do now from here? I can come back here and multiply this by what? I can come back and multiply this by 2 over 1. And also, since here it's same as exponent 1, I multiply by 2 over 1, right? So which means my x is same as 5 squared. And what is 5 squared? This is same as 25. Are we all fine, right? And then when I come here, this is going to what? Now, remember this since it's same as negative 1. Now, here I am not going to have a solution, right? So here it's going to be no solution for our solution, right? It's okay. So I am hoping that, all of us, are in a position to understand all these types of questions and we can answer them whenever we are given, right? So thank you very much for listening.